Okay, so again, we're going to start with area, the space inside two-dimensional shapes. And we just want to make sure that in our answers, we give it in square units. Okay, so first up, the rectangle. Okay, so we studied the rectangle last unit, right? That's a parallelogram where the four angles are all right angles. Okay, so the formula for area of a rectangle is the length of the rectangle times the width. Okay, so usually I call the length the horizontal one and the width the vertical one. But technically you could switch these, right? Because multiplication is commutative, you can switch the order. Okay, but in this case, the area of length times width would just be 6.9 inches times 2.4 inches. Okay, so we do want to be careful with our decimal points. Okay, so let's see, 9 times 4, 6 carry the 3, 24 plus 7, 3 is 27. Then 8 times 1, 13. Okay, and then recall that when you're multiplying decimals, you count up the number of digits to the right of the decimal points. So here there's 1, 2, and then you move the decimal point in the answer in the same amount. Okay, so 1, 2. Okay, so 16.56, but then the units, right? We have inches times inches. So just like x times x equals x squared, inches times inches equals inches squared. Okay, next up, the square. So another shape we looked at last unit. So for the square, our area formula is side squared. So it's really the same formula as the rectangle, right? If you call this the length and you call this the width. However, the length and the width will be the same number because it's a square, right? Square, all four sides are congruent. So that's why we usually abbreviate the formula for a square into just side squared. Okay, so here the side is 18 mi is miles. That's a very large square. Okay, so remember we do affect both the 18 and the units by v squared. Okay, so 18 squared means 18 times itself. This time there's no decimal points to worry about. Okay, but then we also do the miles squared. Okay, so again, those two shapes I'm sure you've seen multiple times throughout the years, but we just want to make sure we remember them. Okay, next, the parallelogram might be a new one. The area for this one's a little bit trickier. Okay, so the formula for the area of the parallelogram, that's going to be equal to the base times the height. Okay, and then one key warning is that base and height must be perpendicular. Okay, and remember, perpendicular means that they form a right angle. Okay, so looking at this problem below, right? So one thing you got to be careful of is you don't have to use every single number in the problem, right? This formula only needs two numbers. numbers, base and height. So even though the problem gives us 5 numbers, they're not all necessarily going to be used. Okay, so again, how do we identify which of these numbers are the base and the height? Again, the key thing is you want to look for the right angle. Okay, so I see the right angle right here, right? And that's formed by this side of 6 and this side of 5, right? So those will be my 2 numbers. Okay, so 6 meters, that'll be my base. And then 5 meters will be my height. Okay, so notice we're not going to use this 5.8 at all because it does not form a right angle over here, and it doesn't form a right angle over here. So it plays no part in the calculation. Okay, so 6 times 5 would be 30. And then meters times meters is meters squared. Okay, and so to help visualize why this formula is the case, so why don't we go ahead and lightly shade in this little triangle of the diagram. Okay, and then now let's imagine, what if we cut that triangle off and moved it over here? Okay, what would that look like? So we'd have this part, right? And then this shaded triangle is going to fit in right here. Okay, but let's look at where the numbers go, right? So this 5.8, that represented this diagonal slice. Okay, and then so this diagonal slice is 5.8. But we don't really care about that 5.8, right? Because we formed a rectangle, and we know that the rectangle only needs length and width, right? The length was 6. And then the height, wrong. The height was the 5. Okay, so hopefully that helps you visualize the reason that we only use the perpendicular sides, the ones with the right angle, because if you rearrange the parallelogram into a rectangle, you see the diagonal side doesn't really matter, right? We only care about the length and the width in the end. Okay, so that's going to be a big theme for today, right? Look for the right angles. Next, the rhombus, again, a shape we studied last unit. Okay, so this one's a little bit different. So the rhombus does not necessarily have right angles on the outsides. So the formula for the area of a rhombus is 1/2 times diagonal 1 times diagonal 2. Okay, so here the 1 and the 2 are just telling the two diagonals apart. They're not actually the numbers 1 and 2. Okay, so why does this formula work? Well, first let's go and do the calculation. So let me just copy down the formula first. Okay, so in case it's not clear, the 8 only represents this part. But one of the properties we learned is that for a parallelogram such as the rhombus, the diagonals bisect each other, right? So this half is also 8. And that means put together, this entire diagonal is 8 plus 8, or 16. Okay, now let me erase this so it's not too crowded. And going in the other direction, again, the diagonal gets bisected. So if this is 12, this is also 12. So put together, 12 plus 12 means diagonal 2 is 24 units in length. Okay, so we want to be careful here. A lot of times in the past, I've made a big deal about make sure you distribute. But in this case, you do not distribute. The reason is there is no adding or subtracting, right? These are only multiplication symbols. So what you do is you just do 2 at a time. So 1/2 times 16 is 8. Bring down the times 24. And then now 8 times 24 is 192. And since this problem doesn't give us the units, we'll just say the actual word units and then squared. Okay, so this is not part of the problem, but if the problem had looked like this, then you would have distributed because of this plus sign. You would have done 1/2 times 16 and 1/2 times 24. But because this is not a plus sign, it's another times, you do not do the 1/2 times the 24. You only use the 1/2 once. Okay, so that's a common mistake we want to make sure we're aware of. Okay, so where does this formula come from? Okay, so if we think about the rhombus with the, let me draw it smaller, with the 2 diagonals drawn in. So this is split up into 4 triangles, right? So if I were to move the blue triangle over here and then the gray triangle over here, you see that it would look like this. Right, blue triangle moves over here, gray triangle moves over here. Okay, so if we look at the original shape, the horizontal diagonal stays the same, right? So this diagonal is unaffected. However, the other diagonal is only half as tall, right? Because we cut off the bottom half and moved it. So that's where the 1/2 comes from. Okay, so before I continue, let me pause and see if there's any questions. Okay, so next the triangle. So again, likely a shape you may have seen in the past, but maybe not for a few years. Okay, so the formula for area of a triangle. It's 1/2 times the base times the height. Okay, and again, base and height must be perpendicular. Okay, so this will probably be the last time we write it, but it's always going to be true. For all of these shapes, we need to make sure that the base and height are perpendicular to each other. Okay, so looking at this triangle, okay, I see my right angle symbol over here. And so the 2 sides involved in this right angle are this length of 12, so I'll call that the base. And then this length of 8, so I'll call that the height. Okay, so notice for the triangle, we have this 1/2 involved. People often forget to include it. But if you think about it, what if instead of a triangle, this had been a rectangle? Well, the triangle and the rectangle, they have the same base and they have the same height, right? But of course, they don't have the same area. the triangle is much smaller. So that's why we need to remember to do the 1/2, because without it, you're telling me it's a rectangle when it's actually a triangle. Okay, so base was 12 inches, height was 8 inches. And again, we don't distribute, we just do 2 at a time. 6 times 8 is 48. Inches times inches is inches squared. Okay, and then lastly, the circle. Again, a shape you've likely seen before. So the formula for the area that we'll use, area of a circle, is so pi times the radius squared. So sometimes you hear it pi r squared. The r represents the radius. Okay, so we want to remember that the radius is the distance from the center of the circle to the actual circle, the outside. Okay, so for this first example, the 12 is the whole distance. So this is known as the diameter. But the area formula does not involve the diameter. It needs the radius instead. So the radius, again, would be from the center to the edge. Okay, so, well, if you look at it, it takes 2 radiuses or radii to make the diameter. So a single radius is half of a diameter. So half of 12 would tell you that the radius is 6. Okay, so the area is then pi times the 6 centimeters squared. 6 squared, 6 times 6 is 36. And then centimeters squared is centimeters squared. Okay, and then we should always order it with the coefficient in front of the pi symbol. Okay, so I also want to make clear the distinction between an exact answer and an approximation. So this right here is an exact answer, because exact means I did not estimate anything. So by leaving the pi symbol there, that's the true value. Okay, so an approximation means I replace pi with a number that's close to it, but not exactly. Okay, so the way we can approximate is by using pi is about 3.14. Okay, so instead of 36 times pi, it becomes 36 times 3.14. Okay, and let me just do this with a calculator. Okay, so every year, a lot of students get these two things mixed up. So please carefully look through and make sure you understand when you leave the pi symbol there, that's exact. When you replace pi with 3.14, which is not its true value, pi goes on forever, 3.14, 1592, and so on. So when you cut it off at just 3.14, it's not exactly the right value. It's an approximation. Okay, so go ahead and for this other circle, please give me both the exact and the approximate value. Okay, so I'll give you a minute to work on that. Okay, so again, you're welcome to use a calculator for the approximation. You will be allowed a scientific calculator on your quizzes and tests. Okay, so this time they did give us the radius because it only goes to the center. So we do not divide it by 2. The exact would be pi times the 5 meters squared. So 5 squared, 5 times 5 is 25. Meter squared is meter squared. Okay, so exact value is 25 pi meter squared. And now for the approximation, we replace the pi with 3.14. Okay, and make sure you see the pi symbol goes away, right? It got replaced with the 3.14. Another mistake I see sometimes is people use the 3.14, but then they also put in the pi, and that's not correct either. Okay, so again, make sure you not only got these 2 answers, but you got them in the correct order. Okay, again, exact has the pi, approximate does not. Okay, so any questions about the first section about the area? Okay, so next we are going to look at a group of shapes called prisms. Okay, so notice these are all 3-dimensional shapes, right? They would have volume, not area. Okay, so what makes these prisms? Okay, so a prism has it has 2 identical faces. Okay, so face is sort of like a side of a shape, right? Like, so right here, I'm shading in a face of this prism. But we call it a face instead of a side because, you know, this edge could also be called a side, so it's kind of confusing. So we use the word face instead. Okay, so prisms have 2 identical faces opposite each other. That's the first part of the definition. There's more, so leave some space. Okay, so what this first part means is if we look at the right face and the left face, right? So these are opposite each other. They're the furthest away, and they're also identical, right? This and this are the exact same shape and size. But you could also have done like top and bottom, right? So the top face and the bottom face are also identical. Or if you look over at what we call a cylinder, right? So the top face is a circle. And if you had X-ray vision and you could see through, right? So a cylinder is like a coffee can or a water bottle, right? Or something like that. So the top and bottom are identical. Okay, so these are all like prisms. Okay, and then the other important part is that they have to have what are called congruent cross sections. And so those are basically like slices. Okay, so if I go back to the top left shape, right? So we already hopefully agree that the left and right sides are congruent. But if I sliced it in the middle, this slice would also be the same as the left and the right. Right? Or if I slice it over here, again, it would be the same. right? So all slices will be the same size. Okay, so on the other hand, so you don't need to draw this, but let's pretend we had like an hourglass, right? Something that looks like that. So here, the top and the bottom are congruent, right? It fits the first half of the definition. But if you slice it in the middle, this circle is smaller than the others, right? So this is not a prism. Okay, so again, if you look at the 6 shapes in this section, they are all prisms, right? They have opposite sides that are congruent or the same, and then you could also slice them along their length, and all the slices are the same size. Okay, so we group these together because the way we find their volume is always going to be the same. Okay, so we're not going to write this, but volume is the space inside a 3-dimensional shape, and the volume is always in units cubed. Okay, so the formula I'll give for the rectangular prism, some of you may have heard this as like length times width times height, which is true, but I'm going to write it area sub base times height. Okay, so, area sub base means the area of the base. Capitalize the board B. Okay, and then I guess I changed my mind. I'll write it one more time. The base and the height must be perpendicular. Okay, so this one is especially important because normally when you think of height, you think about up and down. And sometimes the height is up and down, but it doesn't have to be. Okay, so for example, let's look at this shape below. Okay, so again, I've already shaded in the left and the right faces. So apparently in order to get the volume, I first need to know the area of the bases. Okay, so this base is sort of slanted because we're looking at it diagonally, but hopefully you can see it's a rectangle. Right, so just like we did above, we would multiply 3 centimeters by 4 centimeters. Okay, so the area of the base is 12 centimeters squared. Okay, now to get the volume, right, I said you take the area of the base and multiply it by the capital height. Okay, so we just calculated the area of the base is 12 centimeters, and now we're supposed to multiply by the height. So again, the natural thought is, well, up and down is 4. That must be the height. However, in this shape, 4 is not the height because the 4 is actually part of the base, so it can't be the height. The height is the distance between the opposite faces, right? So the height connects this side to that side. Okay, so the height would then be this distance. Okay, so again, it might look kind of funny to see the height as a sideways measurement, not up and down. But, if you stood this shape up, if you made it go this way, right? So then, okay, the 3 would go here, the 4 would go here, and now you can see, well, the 6 would rotate up here. Right, so that's why the height doesn't have to be up and down, because if you just like topple the shape over or stand it up, it changes. Okay, so however you visualize it, hopefully you understand that the height for this measurement will be 6. Okay, so we have 12 times 6 is 72. And then centimeters squared times centimeters Well, x squared times x is x cubed. So similarly, centimeters squared times centimeters is centimeters cubed. Okay, so just so you know, for this problem, this was not the only way to solve it. So instead of using the left and the right sides, what if I had used the top and the bottom sides? Okay, so now if I use the bottom side, now the area of the base is 6 times 3, which is 18. And now the height is the up and down, right? Because the height connects the bottom to the top. Okay, so we get the same answer either way. For the rectangular prism, which means the side is a rectangle, you can often solve it in multiple ways. Okay, and you could also have actually done front and back as well. You could have done 6 and 4, and then 3 is the height. Right, so with the rectangular prism, you've got a lot of options. The square prism, well, okay, so the area of a square prism, sorry, the volume. Okay, so you actually do it the same way, right? You first find the area of the base, in this case a square, and then you multiply it by the height. Okay, so again, if we could see through this shape, it would look something like this. Okay, so the base then is a square, right, with sides of 5. Okay, so the area of the base, which is a square with sides of 5, is just side squared. So 5 times 5 is 25. Inches squared is inches squared. Okay, and then volume is the area of that base times the height. So again, if I'm using the bottom as my base, that means I need to connect it to the top. So the distance between the bottom and the top is this 14 inches. So that'll be the height. Okay, so next we have a parallelogram prism. Okay, so again, they all contain the word prism, but then the other word is the shape of their base, right? So here, the side was a rectangle. Here, the top and bottom were squares. And so here, this shape is called a parallelogram prism because you can see the front side is a parallelogram. Okay, so why don't you take a minute and see if you can figure this one out on your own, right? So even though I didn't give you the formula, maybe just based on what we've done previously, you can give this a shot. Okay, so the base we probably want to use is the front parallelogram. Okay, so for that parallelogram, we look for the right angle. Okay, so let me actually use a different color. The red's kind of hard to see past. Okay, so the right angle involves the 4, and it involves the bottom. Well, the bottom's not labeled, but for a parallelogram, the top and the bottom are congruent. All right, so this would also be 9. Okay, so then the area of the base, which is a parallelogram, okay, remember area of a parallelogram is simply base times height, and we just make sure that they are forming a right angle. Okay, and then now we can get the volume. Okay, so again, we need to see which of these numbers is the height of the shape. So remember, height, we are connecting the two faces to each other. So we've got the front face, and so the opposite side would be the back. Okay, so to connect the front to the back, the distance between them is the 14. Okay, so the 14 is the height. The 9 and the 5, the 5 is never going to be used. The 5 is a diagonal distance. It doesn't have a right angle. Sorry, I forgot to put the squared earlier. Okay, so we have 36 times 14. Okay, so again, the formula was the same. Okay, so questions on the way we came up with this value? Some of you may have done 9 times 14 and then times 4 at the end, and you probably got the same answer. And so we'll talk later about why that still worked. Okay, but for now, why don't we actually skip the rhombus prism, because that's a kind of a rare shape, and let's look at this triangular prism. Okay, so maybe you figured out by now, all prisms have the same basic formula. Okay, but unlike the rectangular prism where we had like 3 different choices, here we only have one choice of base. Okay, because remember, we need the opposite faces to be congruent. Okay, so let's, common choice again is people want to choose the bottom. Okay, so let's say you chose the bottom. Okay, so the bottom of this shape is a rectangle, but there is no real top of the shape, right? There's no rectangle up here. So you can't choose the bottom because it doesn't have an opposite pair. And you can't choose the rectangle on the left either because there's no rectangle over here to match up with it. Right, so the only choice you have is to choose the front to pair up with the back, right? Because these two are the same shape. Okay, and so here, well, the right angle symbol is not drawn in, right? But we can pretty clearly tell it's this angle. This is way less than 90, and so is this one. Okay, so again, let me give you a minute and ask you to see if you can calculate the volume of this triangular prism. Okay, so for the area of the base, which was the triangle. Okay, so we again only use the sides with the right angle. So the 5 will play no part in this calculation. But actually, remember, this is a triangle, not a rectangle. So actually, I forgot that we have to multiply by 1/2. Okay, so you can actually multiply in any order, right? So you don't have to do the 1/2 times the 3 to create the decimal. You could instead do the 1/2 times the 4 to get 2, and then multiply the 2 by the 3 to get 6. Again, with multiplication, you are allowed to switch the order. 2 times 3 is the same thing as 3 times 2. Okay, so the area of this front triangle is 6, and now we need to multiply it by the height. Okay, so the height connects the two identical sides. So connecting the front and the back is the 11. Okay, so I'm guessing a few people got 132 centimeters squared. That would mean that, like I did, you forgot about the 1/2 in the triangle. Okay, we didn't do a 1/2 in the previous problems because those bases were all squares and rectangles, right? Those formulas do not have a 1/2 in them, but the triangle is what creates the 1/2, not the prism. Okay, and then lastly, we have the cylinder. So technically a cylinder is not a prism because prisms have to have straight edges, but the formula is basically the same, which is why I group them together. Sorry, volume. Okay, so again, if you could see through the shape, you would notice that the top and the bottom are both circles. Okay, so here the area of your base will be the circle with a measurement of 5 right here. Okay, so again, let me give you a minute and see if we can come up with both the exact and the approximate values for this. Okay, so the area, first of all, is pi times the radius squared. So 5 centimeters squared becomes 25 centimeters squared. And then don't forget the pi goes after the 25. Okay, so that's the area, but now the volume, we multiply that 25 centimeters squared by the height. Right, so the height connects the top to the bottom, so that's the 10. So 25 pi times 10, 25 times 10 is 250, and you keep the pi. Centimeter squared times centimeters is centimeters cubed. Okay, and then for the approximation, again, replace pi with 3.14. So again, the pi symbol goes away. Yeah, so again, questions about anything we have covered up to here? Okay, so then next we have these things called oblique figures. Okay, so let's just look at some pictures, right? So here is the type of prism we were used to, and this one is called an oblique rectangular prism, right? Or here is a normal cylinder, and here is an oblique cylinder. Okay, so what's the importance of these oblique figures? Well, they have a lot of the same properties as a prism, right? Notice the top and the bottom are congruent, and also any slice midway through the shape is also congruent, right? So it seems to fit the same definition as a prism, but the key thing is the sides are not at right angles. Okay, so okay, so what this thing called Cavalieri's principle means is that you can basically find the volume the same way we have been doing it. Okay, so the way I like to think about it is, let's say you have a stack of coins, right? So let's pretend you stack up your coins right here. So if you sort of shift them diagonally, there's the same amount of metal in your stack, right? You haven't cut anything away, you're just tilting it. So you can find the volume the same way as before, right? But you don't use this diagonal length, you use the straight up and down length. Okay, so again, as has been the big theme today, the height must always form a right angle with the other measurement. Okay, so for example, let's look at this oblique cylinder. Okay, so we've got several numbers here. First, we can get the area of the base. All right, so this is a circle with radius 2. Okay, so that becomes 4 pi inches squared. Okay, and then so the opposite side is down here. But again, we don't use this measurement because that's not at a right angle. The straight up and down height from this to the ground is right here. Okay, so we need this height. So unfortunately, that is not marked for us. Okay, so this is part of a triangle though, right? So why don't we, well, we know that if this is 5, this is also 5, right? So we can move this 5 over here. And then now that we have a right triangle, we can use the Pythagorean theorem. Okay, so the two shorter sides squared and added up will equal the hypotenuse, the longest side squared. Okay, so again, I'm working with this right triangle to figure out the h. So h squared equals 16, but we need just h. Okay, so h would be 4, and of course we're in inches right now. Okay, so again, that's not the final answer, but it's part of the process. So questions about where this 4 inches, that measurement came from? All right, so then now we can go and find the volume. Okay, we already have the area of the base, which was 4 pi inches squared. And now we multiply it by the height, which is 4 inches. So 4 pi times 4 is 16 pi. Inches squared times inches is inches cubed. Okay, and why don't we skip over to problem 3. So this one's kind of interesting because the lengths have a variable in them, right? R is not a unit; it's a unknown. So we're gonna have to keep R in our answer. Okay, well, we still have another cylinder, right, with a identical top and bottom, but it's slanted. Okay, but first, let's find the area of this top side. All right, so if you look at it from the top, it would look like this. But we don't want the diameter, we want just the radius. So half of 2r, 2r divided by 2 would be 1r, or just r. Okay, so here the r stays in the answer because we don't know what r is. Okay, so then the volume, we take that area and we see that the distance between the top and bottom measured at the right angle is 3r. Okay, so we would multiply the area by 3r. Okay, so the 3 has nothing to combine with, right? And then the pi is there also. And then r squared times r would be r to the 3rd power, or r cubed. Okay, and because this problem doesn't tell us meters or inches or whatever else, we'll just say units cubed. Okay, so again, please let me know if there's any questions. All right, so then let's look at the, let's define 2 shapes that you're familiar with from real life, but we should know their precise definitions. Okay, so I'll just say they're 3D, right? So you guys know that means 3-dimensional. It takes up space. Right, so you guys know like ice cream cones or traffic cones, right? They sort of have a circular base and then they narrow down to a single point. Okay, and so pyramids are basically the same thing. Okay, so the difference is the base is a polygon. So a polygon could be a square, a triangle, a rectangle. It's something with straight sides, right? So it can't be a circle, which is why cones and pyramids are different. But again, like the Egyptian pyramids, that they narrow down to, or I guess narrow up to a single point. Okay, and so to help understand the volume formula for these two shapes, I'm going to play a quick video. So let me switch my screens. Let me quickly get the light just to make it a little bit easier to see for the people here. Okay, so notice these two shapes have the same base, right? Let me quickly go back, right? Same size. Right, but one is a pyramid that narrows down to a single point. The other is a rectangular prism where it's the same size all the way up. Okay, so to compare the volumes, right, how much each shape can hold, he's gonna repeatedly fill the pyramid and pour it into the prism, right? So however many times he has to do it, that will allow you to compare the two volumes. So does anyone want to make a prediction? How many times will he have to fill the pyramid to fill up the prism? Paula? Twice, okay. Any other guesses? Okay, so let's see. Okay, so there was the first one. Okay, so I don't know how you guys are feeling about your guess, but let's continue. Okay, so twice is not enough. Okay, so it looks like it actually took 3 pyramids with the same base to fill up the prism of the same base. And so let's jump to this one. Okay, so here we've got a cone and we've got a cylinder. Okay, and notice they have the same circular base. Okay, so same idea. How many times do we have to fill up the cone to equal the cylinder? Okay, so there's the first one. Second one. And third one. Okay, so in both cases, we see that the shapes are, they're only 1/3 the size of the big shape, right? Because it took 3 of them to equal the whole. Okay, so that means our formulas will involve the fraction of 1/3. Okay, so let me switch my screen back to the worksheet and we'll write that down. Okay, so the volume of a cone then So again, the 1/3 comes from the fact that it takes 3 of them to fill up a full cylinder. Okay, but then after that, the rest of it looks familiar. Okay, and then we saw the pyramid work the same way, right? So the 1/3 needs to be there because it narrows, so it's not as big as the full shape. But then after that, you calculate it the same way. Okay, so let me do example 1. So this is a cone, right? We've got a circular base and it narrows down to a single, or narrows up to a single point. Okay, so looking at my formula, right, volume, I'll just do V, is 1/3 times the area of the base times the height. Okay, so the 1/3 is just a number, right? So that's gonna stay there. Next, let me calculate the area of the base. So I'll do that off to the side. The base is this circle with diameter 18. Okay, but we know that for the area of a circle, we would rather have the radius. So half of 18 would be 9. Okay, area of a circle is pi times the radius squared. So pi times 9 miles squared. 9 times 9 is 81. Keep the pi, and then the units are miles squared. Okay, so we can substitute that in over here. And then we still need to know the height. Again, the base and the height need to be at a right angle. Okay, so in this case, we can see the height is this other 18. Okay, so again, we started with the formula, we calculated the area of the base separately, then we took the height from the diagram. Okay, so again, you only do the 1/3 once. You don't do 1/3 times the 81 and the 18. You don't distribute because there's no plus or minus. Okay, so 1/3 times 81 pi would be 27 pi. And then 27 times 18, 486. Then don't forget we have a pi. And then miles squared times miles would be miles cubed. Okay, so if you have any questions, let me know. Or if not, go ahead and see if you can do the other 3 problems in this section. Okay, so I'm sure you probably didn't have enough time to finish, but let me go ahead and go over them so that you can make sure you know how to do these. So problem 2, the base of this pyramid is this triangle. And remember, for the triangle, it's 1/2 times its base times the height. So we're looking for the right angle. And the right angle is formed by the 6 and the 8. Okay, so some of you, again, may have forgotten to do the 1/2 like I did earlier. Again, the 1/2 is for all triangles, including this one. And the units are feet squared. Okay, and then now for the volume of this pyramid, remember it's 1/3 times the area of the base times the pyramid's height. Okay, so 1/3 times the area of the base we just calculated is 24 times the height of the whole thing, which is 12. Okay, so any questions about this one? Okay, so I think we'll actually save the last 2 problems. We might come back to them tomorrow. But for now, I'd like you to take our exit ticket for today. So if you could go ahead and take out your device and pull up the 6.1 exit ticket.